Hi everyone, I'm a candidate master at Codeforces rated 1988. Oh, my contest is starting in 2 seconds. Started. Let me share my screen. I don't know why my laptop is slow these days. It's irritating, it's annoying. It's like top, it's like very good laptop, I guess. Like I bought the latest version in Mac because companies is reimbursing it. You have a price wheel divided into L sections numbered from 0 to L minus 1. Price will divided into L sections. These sections are arranged in a circle. So after L minus 1, you get number 0. So the price pointer is a section A. Each time you spin the wheel, the pointer moves exactly B sections forward. And so it will be A plus B model. After two spins, yeah, and so on. You may spin the wheel any number of times. After you stop, the section will where the pointer finally lands determines your price. You receive an amount equal to the number. My okay. If you are at A and if you can do plus 2b, okay, what all you can get is the question, right? You're at A and what all you can get if you do plus 2b. I think everything gets splitted into reminder classes of gcd of b comma l. That would be the I know this already, but we have a brute force solution to probably. I think we have a brute force solution that works probably by not visiting something that was touched already, right? By visiting everything exactly once. I think we have a brute force solution, yeah, because constraints are low. GCD is not required because constraints are low, which should not overkill the problem, even though I can solve it instantly. Okay, it's like the maximum place where we can go. Okay. This should work. So what happens is if you're doing plus b plus b plus b, they will be split into cycles, disjoint cycles. So in the disjoint cycle, you'll go and come back. So once you go and come back in that cycle, you're out rating it. Okay, so it should be fine. My Chrome is too slow. Should I open something else? Might be annoying. It might get annoying. after a while. Might get annoying after a while. Chrome is acting shitty. Should I reinstall it? I don't know. I hope at least live stream works right. What the fuck is this? You have a string, an array of n strings, even 8 of on a, and each consisting of lowercase English letters and an empty string s. In the ith step, you should do one of the following: add ai to the beginning of s or add ai to the end of s. In the so we have the structure like a1 goes here, a2 can be either here or here, a3 can be either here or here, a4 can be either here or here. Okay, we have this structure. What is the lexicographically smallest string you can reach after n steps is the question. Okay, sum of it's guaranteed that sum of n over all test cases does not exceed in the total length of strings, then put over all test cases does not exceed this much. Okay, if total length of the string does not exceed this much, then what can we say? See, if you look at it, the first I strings they have something, and then the next string either comes here or comes here. If the next string goes here, even then you want optimal for this. If the next string comes here, even then you want optimal for this. So it's like you find optimal, and then if this is better, you do that, or if this is better, you do that. That's it. Okay, but now we have to see what happens here exactly. If how do you say you have this string? Okay, you have till I whatever the optimal is. Now we have a new string coming up. How do you say keeping which one friend is better? Think of that. Whichever is smaller, that should be in the front, right? So you should be able to judge if this is smaller than this or not. Okay, if this is bigger at some step, exographically, then that goes behind. Okay, so n square should be fine, right? At each step, you check either of them, whichever is smaller, and then you just submit that. N square should be fine, is it? At each step, you compare two things, you compare two strings. I don't get it. But now think about it. If x is less than current, if x is greater than current, for sure current equals to current plus x. Else, if x is not a prefix, then it is then it is x plus cur, because it's not a prefix means it's less somewhere time. Okay, if it is a prefix, now we have to think carefully. If it is a prefix, then look at it, prefix some character this, else prefix prefix remaining. You have, okay, if not a prefix, you have pref rem pref, or pref pref rem. You have these two things, you have to check very carefully which is smaller. Why not just compare both of them? Will it give time limit exceeded? I'm not being sure. Will it give time limit exceeded? I don't know the difficulty of the problems like. Oh, it's getting solved. So maybe this, just this. Okay. Why is it slow? Why is it slow? I mean, we should not be annoyed in the contest, right? Like, how the fuck can we solve difficult problems if you're annoyed? I think Chrome has an issue. I'll just go over some Safari or something and check it. What the fuck? It doesn't. Okay, leave it. Let's try to think about this problem. Why is my stream working at least? Oster thinks that the usual way of factoring numbers is too mathematical, so he invented a new notion called XOR-factorization, which is more computer science-like. For a given integer and a given sequence of integers, s not equals to n for all I is called XOR-factorization of n, if and only if. Okay, for a sequence of integers, if the XOR equals to n only, then we call it XOR-factorization. So given numbers n and k, find XOR-factorization at k that maximizes the sum. You can prove that XOR factorization always exists. Okay, n is big. We have k is less than or equals to this. Sum of k doesn't exist, so it can be done in O of k. We want maximum that. A less than or equals to n. Okay. Sum of ai maximized. XOR of ai equals to n. This is what we need, right? Take all of them as n. Okay. Take all of them as n. And then what? Okay, the condition is some specific bits must occur odd number of times, and all numbers are less than or equals to n. Okay, so for a given number, okay, it's getting tricky a bit. K is this much, not, it won't be too tricky. Okay, What's the max you can get? Oh, okay, wait a minute. If k is odd, keep all equals to n. That's it. Okay, whenever k is odd, the answer is all equals to that. If k is even, okay, we have some bits that must occur odd number of times. Okay, look at something less than n. Okay, it has bits, right? I mean, I should be able to guess that, okay, one will be equals to n, all of them will be less than n or something like that. But leading bit is the one that is. If some leading bit of n is not present in two things, finally, then, okay, I have an answer which is n minus 1, uh, k minus 1 n plus 0. I don't know, I think 0 works. This is one minimum answer we can get. Okay, okay. But I don't think that's the answer. I think that can be the answer. Maybe that is the answer. That seems to be the answer, but should I submit without proving? Should I submit? How can I prove it? Like, think about it well. Okay, I think I can prove it well. Like, if you see the leading bit, it's not finally then. Finally then. If some leading bit of n is not present in two things, okay, let's look at that. Then you can make both of them as 1 1. Okay, otherwise, all of them will have 1 except 1 and 0. That bit has been done. Okay, now if you go further, you're at next leading bit. Where there is 0, you can keep 1, but all of them should be. Wait, wherever there was 0, you can keep ones all over there, right? No, but you cannot keep ones anywhere there. Why? Okay, you have ones and 0. If you have two ones here, you will activate both. So you have ones and 0 in the most leading bit. Now you are looking at the other leading bits. Okay. Now if you look at other leading bits, because all of them had ones, if all the things where n doesn't have anything, they cannot have anything. And when n has something, because if all of them doesn't have anything, also this must be 0. So it must be k minus 1 n and 1 0. You guys are able to see that, right? Look at the most leading bit. There cannot be two zeros here. Why? Then you add two ones there. Okay. Now, because whatever is here, remove them and add one is the best, right? Remove them and add one is the best, right? Now it proceeds that it's k minus 1 plus 0. See? I have proved it well. Okay. The fuck is that? I mean, approved it very well. If you cannot understand, I'm sorry. Try to review it, try to see it slowly. Maybe then you'll understand, okay? Problem is guessable. The fuck? Is it wrong? Why does it only have 20 solves? I thought I have done it, right? All of them once and this is zero. And then we have the other thing. I hope it's because of InQ. I mean, I have seen it well. I have seen it well. Because all of them are zeros, all of once, all of them must be zeros. Now, because of all this, this must be zero. I've seen it well. I won't. I'm confident on that. So now we're at D. Are we scared of D? D should be shitty, right? I want to solve more problems. You're given n different integer points on x-axis. For each point, you have to pick a real value or a greater than 0 and draw a disk of radius Ri with center x such that no two disks overlap. We want to choose values of Ri in such a way that the number of tangent pairs of disks is maximized, and you have to find this maximum value. Okay, seems nice problem. We say that two disks overlap if the area of their intersection is positive. In other words, outer tangents disks does not overlap. To outer tangent disks does not overlap. Number of tangent pairs of disks. What does tangent pairs of disk mean? Oh, like this. Okay, then it's not that nice of a problem. But yeah, let's see the structure. Only adjacent things will get paid, right? Only adjacent things will get paid. To outer tangent disks does not overlap. So you can make the radius 0, right? Or greater than 0. Real value. So you can make it infinitesimally small, right? You can make it infinitesimally small, but you can never make it. Okay, you can make it infinitesimally small, but you can never make it. Okay, one simple thing is only I and I minus one, I and I plus one can touch. Okay. So what's the general structure? What's the most general structure you have? What's the most general structure you have? One doesn't matter. First one doesn't matter. Whatever is happening, it will finally go and touch this one. Okay. So remove one. Now you have two. But the fact is, two has a radius bound. Okay, two has a left side radius bound. Two cannot exceed this radius bound. That's always there. One doesn't have such a thing. Two has this radius bound. So when there is this radius bound, three has this radius bound. It can never. All of them has that radius bound. Radius bound. Okay. We have these conditions like Ri plus 1 less than or equals to Di. Let's say, okay. Okay, we have the radius bound that two size should be less than or equals to that, but it can be as small as possible. Okay, let's just say in optimal two size is something like that. Two size is something like that. Okay, I see the issue here. I think it should be simpler than what I'm thinking here. Okay, see, you have this size and you have this size. Okay, this is limited by this. This is limited by this. If this should be less than this should be less than this, so they can never touch. For people to touch, d- if ri plus 1 greater than di, it's impossible to touch. Okay, this is obvious. Can all of them touch is another question. Okay, just think about it. Here you have two pairs. If this happens everywhere, if ri plus 1 is not equals to di everywhere, then what can you do? Okay, if between two pairs, if that happens less than, nah, what did I mean? Let this be d1, d2, d3. Okay, you have two centers here. If if d1 plus d2 greater than d3 or equals to d3, d1 plus d3 greater than or equals to you have centers like this. Let's say, okay, if d1 plus d2 greater than or equals to d3, then it's impossible. Why? This cannot. This is less than. Then it's impossible. Why? This is less than d3, right? And this is less than d1, right? If one is less than d3 and the other is less than d1, you cannot add up. Both of them are less than d1 and less than d2, because r1 less than d1 and less than d2. In other case, d1 plus d3 is greater than d2. If this happens, there must be a break. Okay, if that doesn't happen, is it always possible is my next question. Okay, if that doesn't happen, if that doesn't happen, you can always increase all of them. Okay, you can increase all of them one by one. Okay, imagine this process. You're increasing all radiuses one by one, slowly. Now few things touch. Now what do? If all of them has touched, we'll try to increase this slowly, let's say. Okay, now increase this one slowly. Let's make all of them infinitesimally small. Now increase this one slowly until it touches this one. If this happens, we must break. Else, can we always form them? Is my question. Else, can we always form them? It's likely we can, but how can I prove it? Like, how can I think of it? Like, we have four things, then we have this D1, D2, D3. If we don't have them, then it's fine. But if we have them within that, like, if all the distances are within that, how do I prove? Go to the minimum D1. Okay, go to the minimum D1 and make it equal on both sides. Okay, wherever the minimum d1 is, make that one equals to both sides infinitesimally. Okay, almost. Now you have everything is infinitesimally small. Let's say everything has very small radius, 0 point something, let's say initially. And now we have smallest d1 in our consecutive things. Okay, make that. So now there is gap here. Now find the smallest d1 again, make that. So then there is always gap. But this side you have this to be the gap. And I think if you're making smallest d1 always, that should be fine. That should be fine. I think that should be fine. I'll just guess it once. It's just a necessary condition. I don't like doing like this. I want to prove well. I want to prove well, but I don't know. My logic of trying to increase the smallest d1 seems fine to me. Why I have to be very clear? Like, how is that fine? How can I visualize that it's fine? It seems fine to me because you can expand everything else still, and you will expand the minimum one. Should I submit this? It's risky, but should I submit this? Think about it well again. You have these things, you have these minimum Ds. Okay, you have these minimum Ds. You can always expand whatever the minimum D1 is, you will go and touch that, let's say. I don't know. Maybe it's not that easy. Maybe you have to do some DP. I don't know. It's not, I don't know how to be clear. I should not guess like this. Let's say whichever side is minimum, then this will expand. Then these two won't touch. I have to be careful here. If all of them are close, is it always possible? If none of them is too far, is it always possible? Is it always possible to have solutions like R1 plus R2 equals to D1, R2 plus R3 equals to D2, R3 plus R4 equals to D3, and so on, if D2 greater than, D2 less than D1 plus D3, and so on. This is the question, right? Is it always possible to have such solutions? Keep R2 0. I don't know, I cannot guess. Problem seems guessable. The fuck? I thought I have seen this, right? All my contests are getting fucked these days. So in even case, all the most leading bit must be ones and this one should be zero, okay? Now let's look at the next leading bit. Let's look at the in-between bits. They should be even number of times, right? So none of them can be one because then they will become greater than n. All of them should be zero. So this also should be zero. And then we are at the next bit. Okay, now we are at the next bit. Now what can we do? Okay, now we can choose one over here. We can choose one over here and we can do ones over here and then we can leave zero there. Now that is small and this is small too. I see. So my previous logic had a flaw. Once zero, and then you'll make zero here, and then you'll make ones here. Okay. It's true that the next row also should have a 1 0 and ones, but the 0 can be somewhere else. Now both of them are less than n. Now you have them taking ones here and ones here too until the next one. Now you are at the next one. I think those two can be whatever. Those two will always be ones from here. I have an algorithm. Okay. I have an algorithm. Take first two bits, make them 1 0 0 1. You take these two things and then you pair them as all, and then they are gone. Okay. Because all of them must have ones now. Because all of them has ones, it continues now again. The same pattern will continue. So I think this seems doable. This seems likely correct. This algorithm is likely correct. I got that. I got that. I got that this should be 0 1 1 1 1. I got that the next all of them must be zeros is what I got. And then I got that this should be also only 1 0 should be here. But if there is only 1 0 here, if there is only 1 0 here and here, you can pair these two things and all of them can end up with ones. And then the problem continues for the remaining things. Okay. Depends on k. If k becomes small, you cannot keep doing it further and further. Okay. What do I mean? Now let's say here you have next one more bit and 1 and 0, and then you have remaining bits. You cannot make this one and this 0 and add those ones over there. Okay. Because all of them are tight, you cannot add and add where you want, where you like, wherever you like. So you have fuck. Let's say you have everything as ends. Okay. And everything has ends and one thing has zero. Now what do? You can bring this one here and make all of these and all of these as zero. Okay. And then you proceed make all of these and all of these as ones. So the XOR is zero. So now what does that mean? You have all zero. Okay, you have all zero and all of these matches to n, let's say. And then what are you doing is you're making this one, and then you have this all zero and this corresponds to remaining thing. Now we are making that zero, so now it became all zero from here. Okay, so we can proceed further and do this further. As long as there are two things, you try to see it like after this bit, after this leading bit, you try to take first two bits, you swap them. One is zero, the other thing is having all ones. Okay, you swap them and then you make all of them as zero, and then you go to the next thing. Okay, so what do I do? We have this, right? And then what do I do? A of 0 equals to 0. There should be two bits to be able to do this. Okay, there should be two bits in n to be able to do this. Okay, we'll try to find two bits in n. Okay, let me just collect bits of n bits. J equals to 30, decreasing order. J greater than or equals to 0, j minus minus. If n and 1 less than j, n bits dot pushback of j. We have again int j equals to 0. Okay, if j plus 1 is less than n bits dot size of. Okay, you have j and j plus 1. I mean, you have two bits remaining. Okay, you have I and I plus 1, you have j and j plus 1. If I is less than k, I plus 1 will also be less than k. You have I and I plus 1, you have j and j plus 1. Okay, what do you do is I is having all zeros. Now, let's say both of them are having all ones. What do you do is, what you should do is, you make one of them zero, you make one of them zero, and then you make rest of them as ones. Okay, let's not do this too. Okay, what do you do is, you say p1 equals to, let it be this, n bits of j. P2 equals to, let it be n bits of j plus 1. Okay, j plus equals to 2. Now what do you do? A of I XOR equals to P1 A of I plus 1 XOR equals to, this is just a pattern. Like I had a pattern in mind, I'm trying to build that pattern now. Okay, so this doesn't have logic. A of I or equals to P2 is smaller, right? So P2 minus 1 means making all of them as ones. A of I plus 1 or equals to P2 minus 1. I think this should work. It's weird. I don't know. I cannot think of some simple proof for this. I hope at least it's correct. It's guessable though. It's guessable. Fuck it. I think I should start with zeros. Why I'm only doing it as long as we can go right, but if all of them are enabled, we should do that. I'll make this zero, okay? And now I'll go ahead with, we'll start with a of I as zero. So now what should we do? We have to activate this, we have to disable this, we have to make both of them that, and then we have to make if I plus 2 less than n, okay, less than k, we have to make and equals to p2. You have to make them zero, then it works. What I did was, initially I kept this one as zero, and then I'm making this one as zero. So I'm making I plus 2 as zero by doing and with that. Wait a minute. I shouldn't just do this. What I should do is, so we have n. I'm trying to remove whatever is here and then do the or. Okay, that should be great. Is it even right? This is zero, right? So what happened was, we have 0, 5, 5, 5. And then what happened? I'm taking this 0 and I'm taking this 5. 5 is 4 plus 1, right? And then what am I doing? I'm making both of them as 1 and 4. So why did it not work? This P1. I'm a candid master for sure. It's 1 hour 30 minutes gone. Fuck. What's wrong? Okay, now when something else becomes smaller, can we activate these bits? You can, but you have these things. The XOR should be 0, so you can only activate twice, so it should be fine, but why is it wrong? It's scam, it's cheating. Why the fuck I cannot solve these questions? Every contest is happening like this. I can see an issue here. The pattern is correct, but let's say we have only two things. We have more bits. I think these two should be inside. If it passes, it's the same pattern, but it's not passing. What about the other problem? Is it DP? If we have something, let's just see how this left side boundary. Okay. What it means if all of this can be in a line? I'm not able to solve this shit too. Both of them are not that difficult. Like, the fuck, so many people have solved them. What's happening to me? Like, how can I prove that? Prove that this is just the answer. If you take this as an example, if these things have solutions, then we are good. Why? R1 less than D1 is held by this, R2 less than D1 is held by this. If above has positive solutions, we are good. Take the minimum, okay, and then make R3 equals to that minimum of D and then subtract that one from this. This will be 0. R3 will be that. So you're subtracting from this and this. So R2 and R3 have been eliminated from equations and you have it. Okay, you need not worry about. If you fix R3 to be D2, you have R4 value fixed. You know all the values. If you know one thing, you know all other values. If you know R2, yes, if you know R1, R2 is D1 minus R2. Okay, R3 is D2 minus D1 plus R1. R4 is D3 minus D2 plus D1 minus R1. And what do we have? D2 less than D1 plus D3. So we have this to be positive. Okay. So whenever this is negative, we have this to be positive. R5 is D4 minus D3 plus D. We want all these things to be greater than or equals to greater than 0. We want all these things to be greater than 0. And if all of them are greater than 0, we are done. Why? All of them are greater than 0 and all of them matches perfectly, so all of them touches perfectly. So what does that give us? So this will give us this is positive. Okay. And if R1 is equals to this, would these things satisfy? I mean, if I keep R1 as maximum of these things, because those are positive, right? So we have this to be positive. But what about this? Okay, this is positive. If you can just make sure, fuck. See, I should be able to know this. When is it possible? Because then the answer is n minus 1 or not, right? To at least answer that question, we should be able to know this. When is this possible and when is this not possible? Okay, we have to know this. We should be able to solve this. Wait a minute. R2 had D1 involved, R3 had D2 involved. Yeah? R1 can be so large, but R1 cannot be larger than these things. Okay. So you want D2 to be less than, you want all the alternating sums to be greater than 0. If that happens, is it done? If all the alternating sums is greater than 0, is it done then? Then you can go till here and you cannot add that to this, whatever you do. That's what it means, right? If all the alternating sums are better than this, so this is a minus of minimum alternating sum, and you can make this. It's not happening. The fuck is this problem? Can I just do something greedy here? If a solution exists where you do minus one here and you do minus one here, you do plus one here. Okay, you do plus one, minus one, plus one, plus one, minus one, you do plus one here, you do minus one here. I think a solution exists where R1 is D1. You can always make R1 as big as possible until this thing keeps reducing. So what I mean is this thing is tight somewhere. I'll just submit this. This is wrong anyway, but I'll just submit it. Why can't I solve it? Why can't I solve it? Time's running. Stupid problems. I don't know why. I can't even call them stupid. Let me see as well. Oh, seems a bit interesting problem, right? What if L equals to R? Answer is 1. Else, is the number small? It can be very big sometimes. I mean, if L2R has from this bit to this bit, what does it mean if there is an X? See, 0 or it is all of them. Under that X, all of them form a permutation. Okay, I can see that there can be more. Let's look at different states in any prefix, okay, or any subset, okay. XORing with these bits, I think there is very specific condition here. Take any bits, the pattern should be, the number of different patterns should be equal. What do I mean by that? If you take any two bits, take any bit, okay. If it has number of zeros and number of ones equal, then it can be 1, else it must be 0, right? That bit will be flipped, right? Okay, some bit can be 1 in X, number of ones and number of zeros in that bit should be equal. And now let's look at consecutive numbers. Let's look at the last one. If number of bits and number of zeros and ones are not equal in this, that must be 0. Okay, take that away. Now we are looking at this one. So it says it must be even, right? Number of numbers should be even, okay? If number of numbers is odd, answer is 0. Okay, now number of numbers is even. So all of them are having 0, 1, 0, 1, 0, 1, that's good. And now you look at this thing 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, and so on, right? Or 1, 1, 0, 0, 1, 1, 0, 0, and so on, right? I'll get some water. This contest is also fun. Take any prefix pattern, okay? Look at any prefix pattern. What does it say? You have different prefix patterns, okay? And if you look at a prefix pattern in L2R, they will occur in a line, in a groups, right? And now what happens to a prefix pattern? They get jumbled among themselves. Okay? One thing is true. All prefix patterns should be. Okay, let's look prefix patterns still here. We have different prefix patterns. What happens to them? The patterns will get jumbled. Okay. The patterns will get jumbled. If you are looking at the patterns. Okay. If the pattern has 0 and 1, this is possible, or just keeping it same 0 is possible. 2s. As we go further, so what is happening here? Either they stay the same, the first two groups, either they stay the same, or they entirely get swapped. Okay. So what does it need? What does it require here? If they are staying the same, or if they're like getting swapped. They are always like these groups, and if you see for new group, it will be again like this: 0 1 0 1, or if this is same, it must be 0 1 0 1. So it's all prefix same, and then it comes zeros and ones. If number of ones is not equals to number of zeros, there is no way. So it's equal number of zeros and equal number of ones. Okay. After some prefix matches, let me see examples. 4 7, right? After some prefix matches, it's 0 4 5, 6, 7. So it should be like this. It should be perfect. It should be two powers. It should be two powers. Otherwise, it doesn't work. It should be two powers. Is this a power of 2? But then the answer is just too simple then. I don't think such a question will be there. Damn, I'm fucked. So now this and this have been paid. Can be paid. Okay. And now again we have to have either one, or there should be a way in which you compare all of them to all of this. And if you see again four patterns, okay, that should be possible. Is it like that then? I'll just guess it. Doesn't hurt. Submitting a wrong answer when contest is already fucked. It should be wrong. I think is it always trying to take the maximum. What happened to me? Okay, if you take different patterns, the pattern will be like 0, 1, 2, 3. And if you have to merge 0, 1, 2, 3 with any of them, okay, 0, 1 should be equal. And then you have 0, 1, 0, 1. If these zeros are more, these ones are less, this 0 should be less and this 1 should be more. That cannot happen, right? So equal again, and then again equal, and then again equal, and then again equal. So what does that mean? It should be all 0, 1, 0, 1, perfect 2 power n. Is that the answer? Four, five, six, seven. Okay, in this case, what can be the answer? It's 2 power 41. Is that the answer? Okay, you have many groups here, and then when you go further, this group will be split into ones and this group is splitting into two. It must split into one and two. And this is just a corner case somehow. I'm ending the stream, guys. I don't know why I'm fucking up every contest. It's sad, right? I don't know what happened to me. It's supposed to be easy. It can be proven. So won't you please call it if a time is through and I don't know it fall apart when nothing's new, nothing's new, nothing's new, nothing's new, nothing's new, nothing's new. Mm-hmm. I'm a pro, guys. I'm a pro. The fuck I mean by pro.